Have you ever sent a text and gotten a reply in seconds? Of course you have. It feels instant, right? But what if I told you the dream of instant long-distance communication is much older than your smartphone? We're talking centuries older. Before fiber optics, before satellites, before even the telephone, there was a revolutionary invention that shrunk the world and kicked off the information age. This is the incredible story of the telegraph. Our story doesn't start with electricity. It starts with sight. Imagine it's the late 1700s, a time of revolution and upheaval, especially in France. You need to send urgent military commands across the country, but the fastest you can go is the speed of a horse. This was a huge problem for Napoleon. The solution? The optical telegraph, or semaphore. Invented by the Schaap brothers, this was a system of towers, each built within sight of the next. Atop each tower was a set of large, movable wooden arms. By changing the position of these arms, operators could spell out messages, letter by letter. An operator at one tower would see the signal from the previous one, replicate it, and the next tower down the line would do the same. It was like a giant, mechanical game of telephone stretching for hundreds of miles. In its day, it was a marvel. A message could travel from Paris to Lille, a distance of about 120 miles, in under 30 minutes. But it had some major drawbacks. It only worked in clear daylight. Fog, rain, or nightfall brought the entire system to a grinding halt. Humanity needed a better way, a method that wasn't bound by the weather or the time of day. The answer, as it turned out, was buzzing all around them, in the form of a mysterious force: electricity. Scientists in the early 19th century were fascinated by electricity and magnetism. They were discovering its properties, figuring out how it worked. People like Ampere, Rørsted, and Faraday were laying the groundwork. They showed that an electric current could create a magnetic field, and that this force could make a compass needle move. The thought quickly followed: if you can make a needle twitch from a distance using electricity, could you use those twitches to send a message? Many inventors across Europe and America started tinkering with this idea. Early attempts were clumsy and complicated. Some designs used a separate wire for every single letter of the alphabet. Imagine a cable with 26 wires inside. It was completely impractical for long distances. Others tried using bubbles in vats of acid or sparks that would burn letters onto paper. Creative, for sure, but not very reliable. The world was on the cusp of a breakthrough, but it needed someone to connect all the dots and create a simple, robust, and practical system. That someone was an American artist named Samuel Morse. Yes, an artist. Morse was a successful portrait painter, but a personal tragedy set him on a new path. In 1825, while working on a commission in Washington, D.C., he received a letter by horse messenger telling him his wife was gravely ill. He rushed home to New Haven, Connecticut, but by the time he arrived, she had already been buried. He was devastated. The slow pace of communication had robbed him of a final goodbye. This event haunted him and planted a seed. There had to be a faster way to send news. Years later, in 1832, Morse was sailing home from Europe. On the ship, he overheard a conversation about the newly discovered electromagnet. A spark ignited in his mind. He realized that an electromagnet, powered on and off by an electric current, could be the key. It could make a mark on a piece of paper from miles away. He spent the rest of the voyage feverishly sketching ideas in his notebook. Unlike the complicated multi-wire systems, Morse envisioned a simple single-circuit system. But how would you send complex messages with just a single on or off signal? This is where the true genius of the system comes in: Morse code. Morse, along with his brilliant assistant Alfred Vail, developed a code that represented every letter, number, and punctuation mark as a series of short and long signals, dots and dashes. They cleverly designed the code to be efficient. The most frequently used letters in English, like E and T, got the shortest codes, a single dot and a single dash respectively. Less common letters, like Q and Z, got longer combinations. This made sending messages incredibly fast for a skilled operator. It was a simple, elegant language for the electric age. With the code and the concept in hand, Morse and Vail built their first prototypes. Their early telegraph machine was a strange-looking device. It used an electromagnet to move a stylus, which would press an imprint of dots and dashes onto a moving strip of paper tape. This gave them a physical record of the message. After years of struggling to find funding and facing public skepticism, many called it a toy or a trick. Morse finally got his chance to prove its worth. In 1843, the U.S. Congress, after much debate, granted him $30,000 to build an experimental telegraph line. The line would run 40 miles from Washington, D.C. to Baltimore, Maryland. Construction was a massive challenge. At first, they tried to bury the wire underground in lead pipes, but the insulation failed. With time and money running out, they made the crucial decision to string the wires overhead on poles with glass insulators to prevent the current from leaking. This decision would define the look of the landscape for the next century, a web of wires connecting towns and cities. Finally, on May 24, 1844, the big day arrived. In the Supreme Court chamber in Washington, Morse sat before his instrument. A crowd of dignitaries had gathered, still a bit doubtful. Morse tapped out the first official message. It was a quote from the Bible, chosen by a young woman named Annie Ellsworth. "What hath God wrought?" In Baltimore, Alfred Vail received the message instantly and tapped it back to Washington for confirmation. The silence in the room turned to astonishment, then celebration. In that moment, the world changed forever. Geography had been conquered by a wire. The commercial potential was immediately obvious. Private companies quickly formed to build telegraph lines across the United States. The growth was explosive. By the early 1850s, lines connected most major cities on the East Coast, and the race was on to connect the entire continent. News that once took weeks to travel by wagon now arrived in minutes. Businesses could coordinate operations. Newspapers could report on events from far away on the same day they happened, and families could stay connected across vast distances. The telegraph fueled westward expansion, managed the growing railway networks, and created a brand new industry with a new type of skilled worker, the telegraph operator. These operators, with their lightning-fast fingers and ability to decipher the clicking sounds of the telegraph relay, became vital nodes in this new information network. But the ambition didn't stop at the water's edge. The next great challenge was to cross the oceans. Laying a cable across the vast, deep, and treacherous floor of the Atlantic Ocean was a monumental feat of engineering, finance, and sheer determination. The man who championed this seemingly impossible project was American businessman Cyrus Field. The first attempts in 1857 and 1858 were heartbreaking failures. Cables snapped, ships were battered by storms, and millions of dollars were lost to the deep. They did manage to briefly establish a connection in 1858. Queen Victoria sent a message to President Buchanan, but the signal was so weak and the insulation so poor that the cable failed completely after just a few weeks. Critics called it a hoax. But Field was relentless. He raised new capital and commissioned the largest ship in the world at the time, the SS Great Eastern, to lay a new, much-improved cable. After another failed attempt in 1865 where the cable snapped mid-ocean, they finally succeeded in 1866. A permanent, reliable telegraph link now connected North America and Europe. For the first time in history, continents could communicate in near real time. This transatlantic cable was the Victorian era's equivalent of the moon landing. It was a global sensation. Soon, a network of submarine cables snaked across the world's oceans, connecting empires, transforming international trade and diplomacy, and creating a truly global news network. An event in London could be reported in New York, Calcutta, and Sydney within hours. The telegraph reigned supreme for decades, the undisputed king of long-distance communication. But technology never stands still. In 1876, another inventor, Alexander Graham Bell, patented a device that could transmit the human voice over a wire, the telephone. And by the turn of the 20th century, Guglielmo Marconi was sending messages through the air with his wireless telegraphy, the forerunner of radio. These new inventions didn't kill the telegraph overnight, but its golden age began to fade. The familiar dots and dashes were gradually replaced by spoken words and broadcast signals. The last commercial Morse code message in the US was sent in 2006, a quiet end to a revolutionary technology. So the next time you send an emoji or join a video call, take a moment to remember the telegraph. It was more than just a machine of wires and clicks. It was the first technology that truly connected us all, laying the groundwork for the instant, globalized world we live in today. It proved that human ingenuity could conquer distance and time, all with a simple dot and a dash. Thanks for watching. If you found this journey back in time interesting, please hit that like button and subscribe for more stories about the technologies that shaped our world. See you in the next video.